Now, in that last worksheet, we talked about moles of atoms and molecules. But here's the thing. You're not really, if you're in an actual lab, you're not going to know the number of moles of anything. You might know the number of grams of a thing. Why? Because you can weigh something on a scale. There's no system of just counting out the number of atoms in a pile of sodium or a pile of gold or a pile of anything. So when you're actually going to do these questions in real life, in any kind of real situation, you're going to know the number of grams. And here's what you're going to do with the number of grams. You are going to immediately convert it to moles. Let's take a look at this problem. You're going to do everything in moles. Every part of stoichiometry is done in moles. What do? You take whatever information you have, then you convert it into moles. Always. Everything's in moles. Let's take a look at this. You have 78 grams of potassium and 19 grams of fluorine gas. How many grams of sodium fluoride can you produce? So let's take a look at this. We begin, as always, with a balanced equation. Here's the balanced equation. 2K plus F2 equals 2KF. And I've already gone and balanced it. Then we're going to take this number of grams. Now, we're not going to write the number of grams here. You know why? Because that's not important. We're going to figure out how many moles this is. And how did I figure it out? Well, I looked at the periodic table. I did some calculations and whatnot. You're going to figure out how to do all that. This is not just turn your brain off and go through steps. You're going to figure out how many moles there are. For this one, I'm just going to tell you what it is. And I'll give you a hint. You have to look at the periodic table to figure this stuff out. But let's take a look here. You have 78 grams of potassium. Well, that turns out that that's 2 moles. You have 19 grams of fluorine gas. Turns out that that's 0.5 moles. Now, remember, fluorine gas is F2. So if you're looking at the periodic table and it looks like the molar mass of F is 19, that's true. But the molar mass of F2 is going to be twice as big of that. In other words, 38. So 19 grams of fluorine gas is actually only half a mole of F2. Let's take a look at this next piece. Now we want to ask, what is the limiting reagent? Which are you going to run out of first? Let's find out. You need twice as much of this as this. But you have 4 times as much of this as this. You have 4 times as many moles of K as you do of F2. So you're going to run out of this F2 first. So what does that tell you? Well, it tells you that F2 is the limiting reagent and that this is going to determine how much of the product you produce. Now notice that for every one of these, you produce 2 of these. So if you have half a mole of these at the beginning, then you're going to have 1 mole of these at the end. And there you have it. What are you doing over here? Now notice, I didn't do anything with grams at all. At the end, you can use the periodic table and figure out how much 1 mole of KF weighs. But notice that I didn't do this calculation. I didn't put grams here at all. I put grams on some other sheet of paper. I only put moles here because all of chemistry, all of these calculations, all of stoichiometry is going to be done in moles and in nothing else. All right, take a look at these problems and do your best to figure them out. Make sure you have that periodic table for reference and see if you can always remember to convert grams into moles and do all your calculations in moles.